Hey guys, so today we're going to be talking about proof by cases. It's an application that is used whenever the proof consists of two or more hypotheses. If we're given off two ways that could imply Q, we need to prove each individual statement first to prove the whole thing. So say we're given phi or psi implies Q. So we assume that phi is true, and using that, we show that Q is true. Assuming that psi is true, we use that to show that Q is true. So therefore, if both of these show that Q is true, the whole statement must be true. Okay, so let's go through an example. If n is an integer, then n squared plus 3n plus 4 is even. We can see already that it's starting to talk about even and odd numbers. If n is an integer, it's not saying whether n is odd or even. So we need to show that for all instances that this is true. So we can say that case 1 is when n is even, and case 2 is when n is odd. If n is even, then we can say that n is represented as 2 times k, where k is an integer. So we can say that n squared plus 3n plus 4 is the same thing as 2k squared plus 3 times 2k plus 4. So this is when we can start doing some manipulation. We can say that this is 4k squared plus 6k plus 4. We can see that we can factor out a 2. And we have basically done it. We know that this whole thing inside here must be an integer if k is an integer under closure. So this is in fact true. Let's go through the instance where n is odd. If n is equal to 2k plus 1, we can say that n squared plus 3n plus 4 is equal to 2k plus 1 squared plus 3 times 2k plus 1 plus 4. Then we can just expand all the brackets. We get 4k squared plus 4k plus 1 plus 6k plus 3 plus 4. Collecting all like terms, we get 4k squared plus 10k plus 8. And then we can see that we can factor out a 2. So we can also show that this is an even number when n is odd. So if both cases branch off to this statement being even, then the whole thing is true. Thank you.